Mahantesh, do you have doubt in second problem?
Yes, madam. That one L2 off, L3 on is there, madam. That only
Huh,
confused, madam.
that is only confused. It is nothing. You see, L2 should be on for 5 seconds. It will get off. Then L3 will be on. That's all. I just wrote it in the words. Okay,
Okay.
let me execute that.
Madam, actually, I am in office, madam.
You can see the recording session now.
Okay, okay, madam.
I will create the program now. Okay.
Okay, okay, madam.
Okay. So, let me take a switch first. Okay, when I switch it on, this lamp will be on for 5 seconds, correct? So let me first I'll go one after the other. Then I will tell the repetition. Okay. Next, we'll on the second lamp. To on the second lamp, I'll take the first timer output. Okay. Then I'll take the second timer. 0 hash 50. So now I want to on second lamp. Oh, see here, till here, when I switch it on, lamp 1 will be on for 5 seconds. Once lamp 1 gets off, lamp 2 will be on for 5 seconds. Once lamp 2 gets off, lamp 3 will be on for 5 seconds. Okay. Now I want to repeat this process, correct? So what I will do, I'll take timer 3. So now this fourth timer is used for repetition. Okay. So what I'll do, I'll take a NC switch here. Okay, understood?
Yes, madam.
Let me simulate this one. One second.
Madam, timer to address not mentioned, madam.
Timer to address is not mentioned. Where? Mentioned.
Output, madam. Timer output.
Wait a second. Oh, here this should be timer 2, right? Timer 4, okay. So I'll put all outputs one side, okay? So that you can see properly. So let me on this one now. So now this lamp is on for 5 seconds. Now this is on for 5 seconds. This is on for 5 seconds. There is a small delay, okay? That's why it is acting like this. No, it is proper. So after this gets off for 5 seconds, then again it is repeating. Is it fine? Okay.
Yes, ma'am.
Any confusions?
No, madam.
Mallikarjun got it?
Yes, ma'am.
Okay. What about the third problem? Traffic light. Traffic light. What have you done? Did anyone give a try for that one? Okay. We'll take a 5 minutes time. Try to solve it if possible. Okay. Otherwise, I'll show that one.
Okay, ma'am.
Okay. You know the condition, right? Should I share that screen? Question? Okay, do it. Sushant, you understood today's problem?
Yes, ma'am.
No doubt, right?
No, ma'am.
You're understanding the concept, no?
Yeah, ma'am.
Okay, if any confusion is there, please let me know.
Okay.
Mallikarjun,
Yes, madam.
what is the difference between this, the problem you're seeing on the screen and the problem you have shared? It is same, right? Only the connection you have changed, no? Observe it properly. From here, you have taken directly timer output. There is no difference. It is correct for the forward action. What about the reverse action? Okay. 1 second.
Question one more time, repeat, madam.
Okay. I'll share the screen. Wait.
Reverse.
See, you know the traffic light, right?
Yes, madam.
So now the forward action is same as the question 2. Correct. That is right. Whatever you have done, it's correct for the forward action. Now, see here, once the green light becomes off, okay, once the green light goes off, yellow light will be on, right?
Okay. Green.
And then red light. What about here? Here, see. Okay. L1, L2, L3. So it is coming from L1 to L2, then L3. From L3 again, directly it is going to L1. Okay. It is not coming to L2. But in the traffic light problem, after green light goes off, again yellow light will be on, and then red light will be on. Correct?
Okay.
So
Yeah.
how are you achieving this condition?
Yeah.
Let's solve this problem.
Okay.
Okay. So now for the forward action, it will remain the same. So therefore, I will change the address. Okay. So I'll change this one to red light, and I'll change this one to yellow, and I'll change this one to green. Okay. Now, the forward action remains the same. Once red light goes off, yellow will be on. Once yellow goes off, green will be on. Now, once the green gets off again, yellow should be on. That means the compiler should go exactly you're sending it to this one. Okay. So for that, what I'll do, I'll take here timer 3. Okay. In NO, and I'll take timer 4. Okay. Understood? See here, what happens is that when I take timer 3, so since it is an on delay timer, after 5 seconds, once the green light gets off, this will get on. Okay. And you are using timer 4 for the repetition purpose. So here is the cycle is that now in the previous problem, you're using it for the repetition, but in the traffic light problem, again the yellow light should be on for certain period. So I'll be considering that delay again here. Okay. So that during that time, yellow light will be on, and simultaneously it will repeat the process as we have used the NC switch here. Understood? Any confusion? Should I repeat again? Is it okay?
Yes, okay, madam.
Okay.
Amen.
Okay.
So now you can see the red light is on. Now yellow light is on. Now green color is on. Again yellow is on. Then red. Any confusions? Others, is it clear?
Yes, madam.
Okay, please note down the problems. And one more thing. So whatever problems I am solving now, same problems you will be doing it for the other PLCs as well. Okay. So I'll be not repeating the questions. You should remember the questions. So make sure you are taking it down. All the questions. Okay.
Okay.
If any extra features are there, then I'll give the problems. If not, the same problems you will be repeating in the other PLCs as well.
Okay,
Okay.
madam.
Is it fine with the timers? Should I give some more problems or shall we go to the next topic?
Ma'am, give us some problem. We will try. You don't need to explain us.
Okay,
Or
you will
give.
try.
Yeah.
Okay, fine.
Yes, madam.
Okay, give me 2 minutes. I'll just check it out.
Ma'am, can you? I want to note down this answer.
Okay, fine. Note down it. Once you're finished, please let me know. I'll just scroll it down. Okay.
Okay. Madam, to count down some processes.
To count some processes. Okay. Let's say, let's take we are doing a filling process of bottles. So we need to count how many bottles are exactly filled. So
Yes.
that time we'll go for counters. Okay. So every PLC supports counters. Okay. Few PLCs have up counters, down counters. Then you have up and down counters. Okay. So up counters, it will count from 0 to 999. Okay, this is the maximum value a counter can count. Okay, so next is a down counter. If you're using a BCD counter, okay, so if you're using a binary counter, it is from 00 to FFF. So this is for BCD. So next is 0 to FFF for binary. Similarly, the down counters, they count from maximum value to 0. Okay. This is again for BCD. And FFF2. 0 for binary. Okay. So the next is up and down counter. So there you can do up counting or down counting in a same counter. You need not to use two counters. Okay. Here in Omron PLC, you have a counter and a reversible counter. Okay, you have two counters. So it is called CNT here. This is a normal counter. Okay, since here is the operation is in reverse order. As you have seen in timers, it was counting the value from 50 to 0. Okay, here also same thing. Even if it is a up counter, it will count from maximum to 0. Okay, and the command is CNT C0, the counter number, and the preset value. Let's say you have to count up to 5 or up to 10. So you can give that preset value. So this is a normal BCD counter. Okay, the next one is CNTR. It's a reversible counter. Okay. So here you can make it increment or decrement. Okay. Again, the range remains same. 4 nines to 0. The range remains same, but you can in between you can increment also, decrement also. Okay. With that, you will get a reset pin as well. In CNTR, you will not get a reset pin. You have to use a external reset. Okay. Whereas in the CNTR, you have a inbuilt reset pin. Okay. Understood? So
Okay.
for this command is CNTR. Again C0, the number which you want to count. Okay. Any confusions?
Ma'am, this reversible counter.
Reversible counter means you will be having 4 pins here. Okay. In the reversible counter. One is for increment.
Okay.
The other one, sorry, 3 pins you will be having. Increment. Decrement and reset. So now increment means let's you want to increase the count, like you want to count it from 0, 1, 2, 3. Okay. That time we'll go for increment pin. Okay. If you want to decrement it or if you want to decrease it, then we'll go for a decrement pin. Okay.
Means it's
Under
a combination of both up and down, right?
yes, it's a combination of up and down. It is just like up and down CTUD. Okay. Similarly, now we are using a command CNT-CTR for BCD. Okay. These are our BCD counters. That means you're giving a value from 0 to 4 nines. Okay. You're using natural numbers. If you go for binaries, like from 0 to FFF, or if you're using a binary timer, then you have to use a command CNTX and CNTRX. Okay. So if
Okay.
then only use the binary counters or timers. Okay.
CNT RX, right?
CNTRX.
Okay.
Okay. Any confusion?
No confusions.
Is it clear?
Yes.
Okay. Uh, Now take a switch. So 0.0. Now same what timer block you have used, you can take the same block only for the counters as well. So you can go to details, find instruction. Here you can go for timer or control. Here you can see you have CNR, CNRX, CNT, CTR. Okay. So select CNT. Then give OK. Operands. As usual, you give it as C0. Okay. So can you see this pin here? There is a small pin here. Here, this one.
Yes, madam. Yes.
So that's the reset pin. Okay. So I can connect one more switch to reset the counter. Okay.
Ma'am, you said for CNT there is no reset pin. For CNTR we have reset pin.
Sorry, I forgot to mention that. Okay. So one, you can use this reset pin. Otherwise, you can use an external reset command as well. And you can
Okay.
use CNR command as well. Sorry, I forgot to tell that. Okay. So let me simulate this one. So whenever I want to increase the count, I need to on the switch. So now you can see it got incremented, but here it will be showing in a reverse order. Okay. So again, set off, set on, set off, set on, set off, set on, set off. Again, if you give set on, it will become 0. Okay. Once it reaches 0, it will become high. I'll show how to take the output as well. Now, if you go again, if you again make it off, again, if you make it on, there won't be any changes. It will remain continuously on. But the count value has been already reached the preset value, correct? But it is not, the output isn't changing even if you increase it. Therefore, you will use a reset switch so that again you can start counting it. Okay. So once you on the reset switch, again the loaded with 5. Okay. Again it will start counting the value. Okay. Understood?
Yes, madam.
So now I want to take the counter output, right? I haven't taken the counter output. So it is same as timer. I'll give here C0 for switch or lamp. Then I will give it to the output. Okay. Understood? Any
Yes.
doubts? Now, for CNTR, let's take CNTR. So here again for CNTR also you can give C0 because it is another type of a counter. Okay. Let me check it. Sorry, it will not duplicate it. Sorry. So up to 255 counters you can use, but if you're changing commands or something, okay. So the same now only 256 counters it will be supporting. Okay. If the command is changed, but the numbers also, the number should not be repeating. Now, if I take CNT 00 and CNTR also 00, it will not take it. Okay. Now, here you can do the forward count, the first pin. To the second pin, it is the reverse count. and at the last pin you can reset it. Okay. So let me simulate this one. Sorry. See, now it is counting 1, 2, correct? Can anyone respond? Am I audible?
Yes, madam.
Yes, madam.
Okay.
Yes.
See, it is increasing, right? The first one is increasing. Sorry, again I made a mistake. The first one is increasing. Now in the second pin, it is, if I make it on, it will decrement. Okay.
Okay.
So first one will be incrementing it till 5. This one will be decrementing. Okay.
Yes.
Okay. So here again I can use it for decrementing purpose. See, now it is 0, right? It will not, you will not get the output until it will reach 5. Okay. So if I operate on this one, if I increment this, now it is 5, right? Still I'm not getting the output, correct?
Yes.
Once it reaches, when you on it for the 6th time, that time output will be high and it will reset the counter automatically. Okay. You need not to reset it. Okay. If you still want, let's say you're juggling between forward and reverse action, that time you can reset it and again you can start counting. Okay. Understood?
Yes. Okay.
Okay. Now, till now, whatever problems you have done, okay, on the timers or the memory problems or the basic problems, you can add counters to all of them. Okay. And you can give, let's say, in the previous problems, we were repeating it continuously, correct?
Yes.
You can set a limit for the repetition. Let's say I want to repeat the particular cycle for 5 times, or let's say I want to repeat the cycle only for 3 times. Okay. So now this is used for the repetition purpose.